Not yet. Not yet. Say 7, 6, see that? Yeah, okay.
All right. Hi, folks. It's nice to virtually meet you at PrestoCon. Today, I'm going to talk about the Presto native Iceberg support. Okay. Yeah. So first, I'll talk about what is Iceberg and a little bit about its basics. And then we talk about the basic status of Prestissimo support of this open table format. And then we'll look at how we designed and implemented it, and then a little bit performance and future work. Yeah, so I think people are all very familiar with this Iceberg. It's an open table format, and I think the most basic answer is it's trying to answer is the so how do we manage all the data of the table over time? So how can we handle insertions, deletions, updates over time, and we can look back in the history and find out what's going on in the past. And this Iceberg design was exactly for this goal. So it's fully ISO compliant, and with the query performance bear in mind from the first day of the design. So it's very good at doing small updates because the table management is at file level instead of unlike Hive, it's using the directories and partitions. So this gives it some advantage of doing the small updates. So starting from last year, we decided that we want to have this basic Iceberg support in Prestissimo. And we started with the read support first. So far we are able to read Iceberg V1 tables with both partition and non-partition formats. And this includes the metadata column path and some metadata tables listed here. So in the future, we'll add more support to read more metadata columns and tables. And the Iceberg V2 support, it's ongoing. So far we are able to read the V2 tables with the positional delete files. And the work of equality deletes is still going on. So with all this read support, we already support the time travel. So you can call a system function rollback to snapshots, or we now support the as of language. So you can give it a snapshot ID or a timestamp. So you can go back to the past. We already did some caching support, which includes the manifest file caching. So manifest file is this metadata file that Iceberg used to manage this the table. So but querying it is quite expensive. So we utilized the library's native manifest file caching support. And now the user can use this, turn on this IO manifest cache enabled to be true to use this. Yeah. Yes. And in addition, we now support create, alter, drop tables and schema, create and drop views, and truncate table. And our team also did quite nice work on the stats collection. So we now support NDVs and histograms. Yeah, and we also introduced some utilities like the query runner. So people can use this similar to the Hive query runner. So you can run simple queries there. Okay, so now let's look at how we implemented this basic Iceberg Read. So for people who's familiar with Presto internals may know well to the left part of this picture. So where is the the basic life cycle of a query? So first parsing, planning, scheduling. So to support the Iceberg Read, so in the planning phase, we need to talk to the Iceberg catalog to get the table metadata. And then we do normal plannings, but there is one more step we added at the end of the planning, which is the Iceberg filter pushdown. This is because vlogs only support the filter pushdown. So we implement this special rule. And then at the scheduling time, we rely on the Iceberg library to do the scan planning. So this includes the partition file pruning done by the Iceberg library. So what we give it is, which table we need to read and what snapshot we need to read. So by default, it will be the latest. And then the Iceberg library would return the splits that satisfies this requirement. And then the scheduling is similar to every other, connector. It's so basically the Iceberg splits will be serialized and deserialized by this Presto protocol. And this protocol is for the Java coordinator to talk with the worker, and the worker is running vlogs as this execution engine. So this split will be translated and deserialized at the worker, and then vlogs will additionally process this this split. Yeah. So now we look at how the positional delete is supported on the vlog side. So as people may know, so Iceberg V2 table has two kinds of delete files. So one is called positional and the other is equality delete. So positional delete is where we have the delete file with all the positions within the base data file, which positions were deleted. And the equality delete just have the values to be deleted, not the positions. So to implement the positional delete, so we already know the positions during the deletion. So we talked about we'll send the connector split to the split reader. So this is a normal Hive split will be sent as a Hive connector split. The Iceberg split will be sent as a Hive Iceberg split. And this is identified by the splits field custom split info. So whenever this is a Hive Iceberg split, will spawn up Iceberg split reader. And the split reader will, take care of reading this Iceberg split. And so add split and next is the basic interface of the split readers. So whenever the add split is called, the split reader would try to prepare the split. So which means it will try to create the readers and row readers. And for Iceberg case, it's going to additionally create the positional delete file readers. And then when the next is called, then this read delete position will be called on the positional delete file reader. And this would return delete bitmap. As you know, so there could be multiple delete files with a single base file. So we'll merge those positions into this delete bitmap and wrap it in the mutation object. And then with this mutation object, the Iceberg split reader can call the row reader to interpret them. So which is basically just convert this bitmap into the original row sets to be scanned. And the rest part is just the reader's job to read and skip those positions. Yeah. And equality delete is similar, but the difference is it creates the equality delete file reader instead of the positional delete file reader. And then the read delete values would interpret the deleted values to be expression. And this expression will be then evaluated as the remaining filter by the Hive data source. So that happens after the actual read. So this is the next call, which means this is a batch read. So after all the data is being read, then this remaining filter will be evaluated. Okay, so our basic performance tests show that our native Iceberg support is about, it's over 2 times faster. So, and this is basically contributes to the vlogs engine. And on the coordinator side and planning side, we still see some differences between Iceberg and Hive, and some of them caused some queries to regress, and we are investigating them. Okay, so in the future, so in addition to optimize the read, we also plan to support insertions and deletions. So insertions, we're currently working on it. So this would be, we need to transfer a few more structures to vlogs to process. And then when the worker returns the result to the coordinator, it also needs to be updated to include more the Iceberg required results. And then the commit will happen on the coordinator by the Iceberg library. And then the next thing is delete. So we do plan to implement positional delete and the equality delete. So there is a limitation of Presto in the positional delete, where it only supports the broadcast joins, because since we want to get the positions of the delete values, we have to join the value with the base table. And this is limited to broadcast join now. But in the future, we'll support it. As the first step, we'll just implement positional delete in the native Prestissimo. Yeah, and equality delete, it's more complex to implement. So we'll need to remove the scan and the join. in this Positional Delete plans. But this would improve the delete performance a lot because we don't have to do this big scan and the drawing. And then with the the read with the equality delete file would also, you know, it relies on the Velox filter push down because some of the filters, if it's one column, then we can push it down to the table scan, and that's implemented quite efficiently in Velox. All right, and we also need to support more metadata tables and columns, and also data cleaning. So the user should be able to clean out the old snapshots they don't want anymore. And for the other bigger part of the data maintenance part, like compaction and so on, we might have some different design. Okay, yeah, so this is our team. So that's the end of my talk. So any questions? Okay, no questions.